Okay, ladies and gentlemen, welcome to the fifth section of Chapter 1, Solving Linear Inequalities. This should be a one video section as there's very little difference between solving an inequality and solving an equation. So just real quickly, let's go over our basic inequality symbols. There are four of them. We have the symbol less than, which looks like that. We have the symbol greater than, which looks like that. We have the symbol less than or equal to, which looks like less than, except we have the added bar underneath, indicating that it could also be equal to. And we have the symbol greater than or equal to, which looks like that. Now, we've done these in Algebra 1. This shouldn't be anything new. Remember that when we're putting them onto the number line, these two symbols represent an open circle because that value, whatever it is not included in the answer. And these two are closed circles on the number line because the value itself is part of the solution set. So keep that in mind, because one of the things that will be different is you will be required to graph your answer on a number line. The only difference, repeat, the only difference, literally the only thing that's different about solving an inequality versus an equation is that when you multiply or divide by a negative number, you must reverse the symbol. So if you divide by -2, you switch less than to greater than. You switch greater than equal to into less than equal to. You flip which direction the mouth is opening. Let's do some examples. I have a total of 5 for this video. What we're going to do is we're going to solve and then we're going to graph our solution on the number line. So in this first equation here, or inequality here, we would be subtracting 47 from each side of the equation, which would give us -10x is less than -40. And then we would divide by -10. Now again, when we divide by a negative number, we must reverse the symbol. So our less than symbol is going to turn into a greater than symbol, meaning our answer is x is greater than 4. Now that symbol, greater than, tells us that we have an open circle. And since it is greater than, we're going to shade to the right. So we have an open circle at 4, and we're shading greater than, which is to the right. Okay, on the next one, we have a variable on each side. That doesn't change much. We're going to subtract our variable to one side and our number to the other. Now you'll notice that one of the things that I accidentally did here was I set us up to have our variable alone on the right side of the inequality. Well, that's not convention. Convention says that we should reverse that. Now when we reverse that, the mouth, which wants to eat the bigger object, is still going to be facing the W. So our answer is W is greater than or equal to -5, which indicates that we have a closed circle. And again, we are going to shade greater than, which is to the right. So we have a closed circle at -5, and we're shading everything to the right. The difference between the open and the closed circle is that in the previous example here, 4 was not included in the solution set, whereas here, -5 is included in the solution set. All right, let's keep going. Third example, we're going to move the x to one side by subtracting 4x, and the number to the other by subtracting 3. That gives us x is greater than 6. So that tells us that we have an open circle at 6, and again we're going to shade greater than or right. So open circle at 6, shade to the right. And then on the last one we have some decimals, so let's clear those decimals out. We're going to multiply everything by 10. So 10 times 1.8 minus 10 times 0.4x is greater than or equal to 10 times 2.2 minus 10 times 2x. That changes this equation into 18 minus 4x is greater than or equal to 22 minus 20x. At that point, we are going to add 20x to each side and subtract 18, which will give us 16x is greater than or equal to 4. And then we will divide by 16, which gives us x is greater than or equal to 0.25, which is a closed circle, and we're going to shade to the right. Again, greater than. So 2.5 is located halfway between 0.2 and 0.3, so we should label it because it's not already labeled. Close circle and shade everything to the right, including an arrowhead on the end to indicate it goes on forever. One more example. This one doesn't require us to graph it on a number line because it's a standardized test question. It says, what is the solution to the inequality 2 plus 4/9 x is greater than or equal to 4 plus x? Now, we've talked several times about how we would like to clear out that fraction. So we're going to do that. We're going to clear out that fraction by multiplying everything by 9. Okay? So 9 times 2 plus 9 times 4/9 x is greater than or equal to 9 times 4 plus 9 times x. Again, when we do that, the 9's in the fraction will cancel with the 9 in front, and then we multiply what's left. 18 plus 4x is greater than or equal to 36 plus 9x. Subtract 4x from each side. Subtract 36 from each side. Gives us negative 18 equals 5, is greater than or equal to 5x. Divide by 5. And we end up with negative 18 fifths is greater than or equal to x, or x is less than or equal to negative 18 fifths would be the correct way to write that with the variable on the left. So that would be answer 1. That does it for Chapter 1, Section 5.